conservation laws. These are based on famous Noether's theorem. It states that for any continuous symmetry in Lagrangian, there is an associated conservation law. What do we mean by continuous symmetry of Lagrangian? We mean its invariance in terms of generalized coordinates, or velocities, or time. Here's an example of coordinate translation symmetry. Let us consider that we have a symmetry that with translation of q by some small epsilon, while we keep other quantities the same, that the change in Lagrangian, which we can write as the difference between Lagrangian with the translated coordinate minus Lagrangian of the original coordinate, and using Taylor expansion we can approximate it as a partial derivative of Lagrangian with respect to q times epsilon. When will the change in Lagrangian be zero? In other words, when is this continuous symmetry enforced? Well, we can see that it happens when coordinate q is cyclic, meaning that partial derivative of Lagrangian with respect to this coordinate is zero. Our space and time has homogeneity in it. In particular, space homogeneity that means that the laws of physics are invariant to translation. That in turn means that partial derivative of Lagrangian with respect to vector coordinate is zero. And we know that this means that linear momentum is conserved. Another property of space is space isotropy. It means that there is no preferable direction in space, or invariance to rotations. For polar coordinate theta, that will mean that partial derivative of Lagrangian with respect to it is zero. And as we have seen, that gives rise to angular momentum conservation. Another property of space and time is time homogeneity. It means that time flows without bumps, so there is no preferable moment of time. And that means that Lagrangian does not explicitly depend on time. We have derived alternative Lagrange equation in the past, which reads the following. Because partial derivative of Lagrangian with respect to time is zero, we have the conserved quantity, which we have identified as energy. So the consequence of time homogeneity is energy conservation.